everyone, welcome to today's episode. It's around episode 5. Yeah, so last time you remember we had started electric current. We had looked at resistors, resistance, we calculated voltage, current, all those we've been doing in our episodes. Now into our next episode. For today we're going to look at electric charge. Sorry for not introducing myself. So I'm Madam Naomi, and welcome to today's episode. So for today we're going to look at electric charge. Is under the second unit, but it's still under a different a different content, but it's still the same electricity. So for today we're going to look at electric charge. So for today is electric charge. Electric charge. Yeah, so here under electric charge, we're going to focus more on static electricity. Yeah, so for today we're going to look at we're going to focus at static electricity. Yes, so you're going to realize in this subtopic, you're going to realize that most of the work we're going to cover is experiments. We're going to do more practical work, but we're going to explain. We might not do physically, but we're going to explain. Yes, so I'm going to start with a very brief introduction, which is going to run us throughout this subtopic. So we have two types of charges. Yeah, we have two types of charges. Two types of charges. We have a positive charge and negative charge. We have positive charge, and negative charge. Yeah, so we're going to, at the end of this, this subtopic, you're going to realize we're going to focus on these charges, how we create charges, some of the experiments, and so on. So we have two types of charges, that's positive and negative charge. So I want us first to understand an atom, how an atom is, how the structure is, and how these charges are distributed. Yeah, so we have the structure of an atom. Structure of an atom. The reason why I want us to understand the structure of an atom, you know, when we define an atom, and you've done it, I think, in chemistry, even here. Yeah, so an atom is the simplest particle of a substance, the simplest particle. So, the reason why I want us to understand an atom, because each and every substance is made up of atoms, and this atom has charges and it has subatoms. Yeah, so that's why we should understand this, so that we may understand the whole content. Yeah, so the structure of an atom, of course, this is an atom. An atom is made up of a nucleus and some energy shells. Yeah, so this one is our nucleus. This one is our nucleus, and inside the nucleus we have subparticles, which are the protons and neutrons. We have the protons. These are the protons, and we have neutrons. Yeah, so the positive ones are the protons, and of course we have what? We have neutrons. And around the nucleus we have the shells, and around the shells the particles found there are called electrons. The electrons are orbiting around the nucleus. Yeah, here. So these ones are called electrons. These are the subatoms which make up an atom. And now you can be asked, can you name 3 subatoms which make up an atom? You simply say neutrons, protons, and electrons. And most of the time when they ask you such kind of question, they make sure you at least you say where they are found in an atom. So we have the protons, and the neutrons are found in the nucleus. So in the nucleus, you simply write, we have protons and what? And neutrons. And of course, each and every particle has its charge. Electrons, before I forget, the electrons, you say they're found around the energy shells. Yeah, sometimes some people can call it energy levels, all that, but we call them shells. Yeah, so the protons are positively charged. 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 And the neutrons have no charge. The protons, so the protons are positively charged. Positively charged. And the neutrons have no charge. The neutrons have no charge. They are neutral. And the electrons, from the symbol, electrons, yeah, electrons, they are negatively charged. They are negatively charged. Yeah, so understanding the structure of an atom, where the subparticles are found, what the charges they are having. So we're going to narrow down to we still under that structure of an atom. So now, what is the overall charge of an atom? What is the overall charge of an atom? Charge of an atom. Of course, an atom is neutral. An atom is said to be neutral. An atom is neutral. An atom has no charge. Why? An atom has no charge because the number of positive charges, particles, and negative particles are the same. So here, it means that the number of protons and the number of electrons are the same. So they cancel out. That's why we say that an atom is neutral. So this is because the number of electrons, of course, these are negative charge, negative particles, and the number of protons, of course, they are positively charged particles. Positive charges are equal. So we have equal number of positive and negative particles. They are the same, so they cancel out. Okay, after looking at the structure of an atom, we're going to look at how do we charge materials. How do we charge what? Materials. And the materials we're going to charge here, they are insulators. We're only going to deal with insulators. We're not going to deal with the conductors. Yeah, we're going to charge insulators. Yes, so we're going to look at, it's good. I don't want to assume that everyone knows examples of insulators and conductors and everything. So it's good at least I do some recap or something. Okay, so we're going to charge insulators. And when we talk about insulators, we mean these are materials that do not allow electricity to pass through them. So these are materials that do not allow electric current to pass through them. Okay, it's not only electric current. Yeah, you can be told, can you describe what insulators are in terms of heat? Yeah, insulators, they do not allow electricity. They neither allow electricity to pass through them nor the heat. Yeah. So examples of insulators. We have so many of them. Examples, but I'm going to name 3. Examples of insulators: we have wood, we have plastic, we have rubber. These are the common ones. I think these ones, everyone knows them. Yeah. So, and the vice versa of insulators are conductors. Of course, conductors, they allow electric current to pass through them. Conductors, materials that allow electric current current to pass through them. To pass through them. Now, of course, most of the time the conductors are metals. Yeah, the examples, metals. We have metals. Examples, metals, yeah, most metals. We also have others like zinc, copper, iron. We have so many of them. We just name a few just in case. Yeah, so sometimes they can give you a very simple experiment to test whether you understand what insulators and conductors are and what follows when they are connected in a circuit. So you can be given a simple circuit here. Last time when we were looking at simple circuits, we drew so many. I don't know how many of them, but we really did a lot. Yes, so you can be given a simple circuit here. Of course, this one is a cell. We have a switch here. This switch is closed. Then we're going to have a bulb here. This one is a bulb. And they are going to leave some space here. They're going to leave some space here. Yeah, we have a gap here, gap A and B. So they can tell you, yeah, so I want to make that switch closed properly. Yeah, so you can be given a simple circuit and they will tell you that there is a gap A, B, and they tell you that copper was used to connect gap A to B. Explain the observation. Explain the observations made. Remember, I'm only doing some brief introduction, which is very, very key to what we're going to learn ahead. So, and most of it is recap. Yeah. So, copper is used to connect gap A to B. Like, explain your observation. So, the first observation you should the observation which should be made here should be concerning this bulb. What will happen to the bulb? We all know the work of the bulb is to do what? To give us light. Yeah. So, after glowing. Yeah. So, when copper is connected here, we all know copper is a good conductor of electricity. So what we expect here is this bulb will glow. Why will bulb glow? Because copper is a good conductor of electricity, and now it's going to complete the circuit. So you say here, the bulb will glow. This is because copper is a good conductor. Copper is a conductor of electricity. And it will complete what? It will complete the circuit. Yeah, so just in case they ask you what will happen when we connect rubber here or something like plastic, something like that, you simply say that the bulb will not glow. Why? Because rubber or plastic or wood is not a good conductor of electricity. So that's why it will not be able to complete the circuit. And last time, I remember when we were talking about complete and incomplete circuits, we said a complete circuit is shown by the glowing of the bulb. When we have the switch being pressed, and then the bulb is going to glow. That's when we say the circuit is complete. Yeah. So we're going to narrow down. Yeah, we're going now to narrow down charging materials. And the materials we're talking about here are insulators. Charging materials, the insulators by what? By friction. Friction. Yeah, so we all understand what friction is. Other than friction being a force that opposes motion, movement, friction is going to create some charges. Yeah, just a simple illustration to show friction. When you're rubbing your hands, yeah, when you're rubbing your hands, you feel like some heat being generated. That's the creation of what? Charges. Yeah, we're going to charge materials here by friction, and I'm going to start with the first experiment. I think we're going to look at 4 of them. If we might not look at them, all of them during this episode, we're going to cover them in the next episode. But we're going to start with the first one. The first experiment we're going to use here, we're going to charge a rod. Yeah, so here we're going to use a rod and piece of cloth. A rod and what? And piece of cloth. Yeah, so we're going to charge a rod here. We're not going to charge this cloth. Yeah, we're going to charge a rod. Of course, our rod here is going to be made of a material which is not a good conductor of electricity. Yes. So how are we going to charge this rod? We have so many ways. You see, even when I was rubbing, that's one example. But this rod, we're going to rub. We're going to rub this rod against even a sleeve, something like even, you can even use your hair, especially when you have rough hair. Yeah. So we're going to rub this rod against the sleeve of a cloth. Yeah, so the procedure is rub the rod on a sleeve of cloth. After rubbing that rod on a sleeve of a cloth, you're going to bring that rod near, you're going to put it closer to the cloth. Then you see what happens. Then bring the rod closer to what? Bring the rod closer. You bring the rod closer to the cloth. Bring the rod closer to the piece of cloth, So this is the procedure. Now observation. What is going to happen? Observation. You're going to realize that this rod is going to stick on, the cloth is going to stick on that rod. Yeah, so here, the piece of cloth will stick on the what? On the rod. Let me draw the illustration. Maybe that one will make things better here. Let me draw the illustration here. We have our rod here. You remember last time I told you I'm not very good at drawing. Yes, so we have our rod here. This rod, before rubbing it against the sleeve of a cloth, it has both positive and negative charges. And now we have our piece of cloth here. Of course, the piece of cloth also has what? Both positive and negative charges. Yeah, so this one is A. And now, after rubbing this rod against the sleeve of cloth, after rubbing it, it might gain positive or negative charges, depending on what you're going to be comfortable with. Yeah. So we're going to rub this rod against the sleeve of the cloth. I'm going to assume that it will become positively charged. It will become what? Positively charged. So, B here, after rubbing this rod on a piece of cloth here, what is going to happen here? The cloth is going to stick. The cloth is going to stick. This cloth is going to stick on that rod. What is happening here? When we rub the rod here, we assume that the rod becomes positively charged. And I've told you that you're going to choose the one you'll be comfortable with. You can say either the rod became negatively charged. Yeah, so for my case here, I'm going to take that we assume the rod became positively charged. And what happens when we bring the cloth closer to that rod? It will the positive charges are going to attract the negative charges. Yeah. So Let me do some correction here. Yeah, so let me draw it well. Let me redraw it. So we have our rod here. We have our rod here. And I told you for my case I'm going to pick the positive charges, and now the negative charges are going to be attracted. Yeah, of course the positive ones are going to repel to the other side. Yeah, so what is happening here? The positively charged rod by rubbing is going to attract the negative charges on the cloth, and now that's attraction. Yeah, that is attraction. So the explanation is very key, because at the end of the day what is going to matter here is explanation. Yes, explanation. You say the piece of cloth stuck on the rod because rubbing the rod will make it positively charged. And remember, I'm only explaining to what I concluded. You can say it became negatively charged. We'll make it positively charged, and the positive charges on the rod will attract what? Will attract the negative what? The negative charges on the piece of cloth. Yeah, so this is what is happening. What I want you to do is this. You are the one to conclude whether the rod was positively charged or negatively charged, depending on what you'll be comfortable with. Now, there's something you have realized here. There's something here, attraction, all that. Yeah. So, when I talk about attraction, you know, someone, I don't want to assume. I said I won't assume anything here. Yes. So, this is what is happening. We say like charges repel. Like charges do what? Repel. This is what we mean. When we have a negative and a negative, they repel. The force of repulsion. You feel like they're moving away. Of course, a positive and a positive, there is repulsion. And the vice versa, of course, is true. Yeah. So we say unlike charges attract. Unlike charges do what? Attract. Of course, positive and negative. So this is what is happening here. We have that piece of cloth sticking on the piece of rod because there were creation of different charges which attracted. Yeah, that's why it was sticking. It was sticking on the what? On the rod. Yeah, so this is the first experiment. I told you we have around 4 of them. Yeah, we might be having 3 to go. Yes, and they're very simple. As long as you have understood the first illustration, you're going to understand almost all of them. Yes, so, and most of the time in this kind of questions, they ask applications. We might discuss all those 4 experiments, and at the end of the day, you're going to be tested with a different one. Yeah, so that's how I wanted to get an introduction. Yeah, and what I want you to understand here before I wind up this, yeah, there's something here. Sorry. Yes, and there is something here. We have a creation of positive and negative charges. How is it possible to create these charges? We say gaining of electrons is what? Okay. That one is the chemistry terms. I don't want to use chemistry terms, but I will have to use them. Yeah, so we have here, we have how do we create a positively charged object? When we have losing of electrons, we create positive charges. But when we're gaining, we create negative charges. But when we are losing electrons, we create what? We create positive charges. So this is what I mean. Positive charges Positive charges, how do we create them? By losing of electrons. Losing of electrons. And most of the time, the positively charged, all those substances, in chemistry, we call them cations. Yeah, but here we're not going to use those terms. And now we have negative charges. Negative charges. How are they created? By gaining electrons. By gaining over what? Gaining over electrons. Yeah. Of course, to understand this better, you know, when we have the electrons, we say they are negatively charged. So when you gain more negative electrons, of course, you create negative what? Charges, and the vice versa. Yes. So I can have two sample of questions that you can be asked that are very testable in this part of introduction. Yeah, sample questions. I'm only going to write around 2 or 3 sample questions. Sample questions. They can tell you, draw the structure of an atom and name the subatoms. And you name the what? The subatoms. Full stop. And the second question, no, this one is 1A. This one is 1A. And 1B, they will tell you, where are these, the name, one, okay, no, what are the charges? Yeah. What are the charges? What are the charges of the named subatoms? Subatoms. The reason why I didn't ask like where are they found, because it's automatic. After you naming, you can at least locate them where they are found. Yes. So, and another question they can be asked, they can draw the rod and the cloth, and they tell you, can you explain the observation and all that? Yeah. So this is going to be a very simple topic. It's going to depend on though it's going to depend on how you're going to understand. Yes, so for today's episode, we're going to wind up at that place. We will continue with the rest of the experiments in our next episode. Yeah, we're going to go. And this topic only needs around 3 episodes, only that, and we are done. Yeah, so I've been your teacher, Madam Naomi, and I will meet you in our next episode. Thank you for joining us today, and I hope you're going to enjoy for the rest of the episode. So this is Horizon TV and Andalusia Academy. Thank you so much for your time.
Are you looking for a school that nurtures your child's academic, spiritual, and personal growth? Andalusia Academy International School, where your child's future is our priority. We offer comprehensive education levels, kindergarten, Pearson I Primary Certificate, secondary and Pearson IGCSE Certificate.
We are a school that emphasizes in the Deen and Dunya. It's integrated in that on the side of Islamic studies, we have Quran, we have Hadith, we have Arabic. And then, of course, in the secular side, we have all the subjects.
We focus on student-centered learning, where we engage our students in different levels. Other than that, we have very innovative teachers who help to cultivate creative thinking, problem solving, which are very, very key skills in our learners, not only in school, but also for their future.
Hello everyone, my name is Aisha Muhammad and I'm a student under Andalusia International School. I've been here for the past 5 years and I'm in year 11 right now, and my experience in this school so far has been amazing.
Admissions are available. Visit us today. We are located in Nairobi, South Sea, Andalusia Academy International School, where your child's future is our priority.